Nuclear power plants are so impressive because they harness nuclear energy. A tiny nuclear pellet the size of a walnut can release energy equivalent to 2,000 liters, about 12 barrels of diesel. In a nuclear reactor, tens of thousands to hundreds of thousands of such cylindrical pellets are typically made of uranium oxide and then encapsulated in an extremely heat-resistant metal alloy to form fuel rods. Multiple fuel rods are loaded into pressure tubes to create fuel assemblies, which are placed in metal chambers alongside control rods and coolant, all housed within a thick steel reactor vessel. This is then placed in the reactor building. When the reactor starts, a neutron strikes nuclear fuel, triggering a fission reaction. In this process, neutrons are absorbed, making the atomic nuclei unstable and causing them to split into two or more fragments. Nuclear fission releases enormous energy, mostly as heat. The fission fragments also emit neutrons, which then collide with other fuel nuclei, triggering more fission. This chain reaction sustains itself in the reactor. Coolant flows through the fuel assemblies to absorb heat. Coolant transfers heat from the reactor to the plant's steam generator. Common coolants include water, heavy water, or helium. The heat is transferred to external water or steam in the steam generator's pipes, heating it into pressurized steam. This steam drives turbines that spin generators to produce electricity. In the end, it's all about essentially boiling water, just with a different heat source. But you might wonder, could it explode like a nuclear bomb? Rest assured, nuclear bombs require highly enriched and compact uranium cores to create uncontrolled chain reactions. Reactors use low-enriched uranium dispersed in pellets and rely on control rods made of neutron-absorbing materials to regulate the reaction. These rods adjust neutron levels to maintain stable energy output. So, no, reactors can't explode like bombs. Now you get it.